Hey there, math fans. Continuing this little intro to a few calculus projects. This one's going to be about hyperboloids and their volumes. This I find just visually interesting, something I've thought about quite a bit and made some 3D prints for. But this is the project itself. So I'm going to introduce, I find a lot of students taking a Calculus 2 class haven't really been around hyperbolas, definitely hyperboloids. And so I made this little visual project to kind of take a step through it. Now, one thing I find interesting is the fact that they are every point on them is on a line, even though they're a curved surface. So I take basically it's a chance to do a volume of revolution, but I answer a question that I've thought about before and never sat down and done. So here's the question. So you've got this. It's if you take, I put a couple dots here. But I've put some equally spaced string connecting two plates that are equally spaced apart. And then I'm going to slowly rotate the bottom, keep the top fixed. Now when I do that, this is flexible string, so it's going to move like this. Now as you watch that bottom piece go, it gets skinnier in the middle. I'm going a little too slow. Is this ever going to be done? So let's go forward a little bit. It makes hyperboloid. All of those lines are on a hyperboloid of one sheet. And if you keep going, where you've rotated 180 degrees, you can see where it's moved to. You get a double cone. I've known that for a long time. I thought it'd be interesting to compute exactly which hyperboloid it is based off of the rotation and know what the volume is. Also, it would be interesting to know, like, the surface area. How do those things change? So I asked some of these questions in the project. I ultimately found these. Ooh, I moved things around. So I messed it up. Let's see if I can fix it here. So I found it, and that was a bit of a chase to get that to come out. But I would want people doing the project to find it, kind of go through that same chase with me, find the volume of that, and then ask other questions. What if we increase the radius of one or the other? What if we change it in some way? I think there are lots of questions I can ask here. And it's a nice introduction, chance to use volumes of revolution and see this. This idea of lines on a surface is actually a big idea in math. If you go to cubics, you cannot have an infinite number of lines. You have one of a few possibilities. The most you can have is 27. This can have an infinite number of lines on it. So these are important problems that people have studied. I don't know that much about them, but this is a pathway to this sort of research. I hope you find that interesting.